All right, welcome back. Section 8.5. This is section 8.5, part 2. And by the way, this is problem 8.5.29. You can see the problems in your book, at any time. We have this question. All right, so here it is. X minus 1 over x plus 3, x plus 4 squared. This is a repeated linear factor. So the setup is, keep in mind we don't know these numbers yet. We want to find them. But we do know what the denominators are going to look like. I take the x plus 3. I take one of the x plus 4s, meaning I don't put an exponent there. And I take x plus 4 squared. And I think last time I said this, if that were a cube or higher, I would just do another one, use the next letter of the alphabet like D, x plus 4 cubed. But, highest exponent we have here is squared, so I just have to write all of these down. All right. LCM, not a surprise. It is just the denominator. Because I want to clear the denominator, I'm going to multiply by x plus 3, x plus 4 squared. That's going to cancel all of this if I multiply it by that. So I'm just going to get x plus 1. For this term, the x plus 3 is going to cancel, but only the x plus 3. And that's going to give me a times x plus 4 squared. When I multiply the second one by the LCM, it's going to cancel one of the x plus 4s and give me the x plus 3 and one of the x plus 4. So there's no square here, for example. All right, and then this one is actually the nicest one. I always like this last one because it has the higher degree. So this is x plus 4 squared. So it's going to cancel this entire x plus 4 out. So I'm just going to get c times x plus 3. We're going to look at this one again later for forbidden factors. Let's actually talk about those. What are my forbidden values of x? Just real quick. There's just two of them. 3 and negative 4. Negative 4 is forbidden twice because it doesn't work there either, but we're going to use that on this line, but before we do, I'm going to go through the formality of setting this up. 1x minus 1, multiplying everything out. It gives me this system of equations. Well, let's look at our last equation here. Multiply everything out. I get a plus b x squared. So a plus b x squared. I get, if I just take all the terms with just x in them, there are 3 terms, and I put all those together, and it's 8a plus 7b times x. And then the parentheses is just for emphasis, but these are just the constant terms. All right. One thing I didn't include here is there is an invisible 0x squared, if you think about it, on this side. And the reason why I want to think about there being a 0x squared here is because I have an x squared. So what do I do with a plus b? What coefficient is it equal to? Well, a plus b has to equal 0 because there aren't any x's here, so there aren't any x squareds. So a plus b equals 0. It's really nice when you get something with only 2 terms in it, because these have more. Which, no matter how you decide to solve this problem, it's more work if you have multiple parts to it. Now, I call this the formality. We went through all of this. You just never know in advance how many of these you're going to need in this process. I won't need all three of them, meaning, maybe I did a little more work than I needed to get this, but, it's once you do it a few times, this part's not challenging. You're just shuffling terms and, putting parentheses around them. So I do want you to, give this a chance. Make sure you think about this, even if you're not going to use all of this. Because remember, we have something not emphasized very heavily in the book, but it's really, really helpful. That is, we have those forbidden values. So I just recopied the line that I circled earlier. This is the first line we get when we clear fractions. And x equals, not -3, or is it? Yeah. X equals, it is -3, is my, what was throwing me is, I didn't really copy it right. Yeah. There were no negatives in the parentheses in this problem, only pluses. But, all right. What does -3 do? Do you see it? It makes this a 1 inside the parentheses. It makes this a 0 inside the parentheses. I don't really care that it makes that a 1, because once you're multiplying by 0, it just makes the whole thing 0. And it even makes this a 0. So I get 1 times a. And what would a -3 do on this side of the equal sign? -3 minus 1 would be -4. So look how quickly I find out that a is equal to -4. Once I have that, let's take a look at this line right here. It is a plus b equals 0. So if a is -4, b is going to be +4. So we have most of our solution here. We know A, we know B. The only thing we don't know is C. I'm going to go ahead and use this one right here for C to find it. Let me put the work down here. That's a little noisy. Put it there. Okay. So what do I have? I have 8A plus 7B plus C equals 1. But remember, A is -4 and B is 4. So I have -32 plus 28 plus C equals 1. Looks like I'm going to get nope, just a 1. If I add 4 to both sides, C is equal to 5. So can we see it all here on my page? Oh man, I was off the page there. All right, I was talking about this, but I just noticed I was off the screen. I took the line and substituted my A, my B, and solved for C. And this, by the way, is something I want you to recognize. Once you know 2 of the values, you can just substitute those in and you found the other value, the missing value. So I have my 3 numbers. Going back to the beginning of the problem, do you remember? A was -4, B was 4, and C was 5. So I did get the decomposition. In other words, I found out what my A, B, and my C were. All right, that's a good problem. The only thing that we're going to add to this, and I'll do that on the next video because I don't want these to be terribly long, is if you look at this video, notice how it's not factored. So finally, you have to get pretty high up in the homework. You know, I think our highest number is in the 40s in this particular section. But this isn't factored. So I need to factor it. Now this one factors pretty easily. I can factor out an x. I get x squared minus x minus 6. And then I factor the x squared minus x minus 6, and it's x minus x plus 2, x minus 3. Hold the whole time copying this down. But for that reason, I have a review of factoring. So this one's pretty huge, but let's say you had some polynomial over this, x or something, and you wanted to do the partial fraction decomposition of something this large. Well, you'd need to factor it. So I'm going to review that so we can do these bigger problems where they might not be factored. And that's it. We're going to skip the unfactorable situation, the other situations where the problem doesn't factor into linear terms. Anyhow, I'm getting ahead of myself, so I'm just going to stop this section, this problem, right here. After you find A, B, and C, you're pretty much done with that example. And we'll have a third part to section 8.5.